We now come to a Q&A session where we welcome your questions. Gentlemen, could you join us? Please do. Well, you've heard a good solid introduction to networking in broadcast and broadcast-like sound environments this morning. Would I be right in thinking that networks are important for your futures? Silly question, show of hands? Good. Questions?
I've got one to start with. I think Jan should be allowed to answer some of the criticisms of AVB. I think you've got a bit of a rough ride here this morning.
Well, it can be much worse, I think. I think there is a couple of things that I'd like to say. First of all, there's this notion of special switches. I think this is a kind of a misnomer. All switches that are currently manufactured can actually do AVB. It's just the firmware that needs to be written by the manufacturers. And that's no different than any of the other gazillion protocols they have implemented over the years. So let's get rid of this notion about old and new switches is just another evolution of switches. And in fact, all the switches that can handle PTP, they can also be AVB compliant. So that's one thing I like to get off my chest. Secondly, it was talked about Dante supporting AES-67, which I think is a great thing. What was not mentioned is that Dante has also announced to be AVB compliant. So that means if that happens, then the graphs that were shown will also look quite different, I think. And then I think, if you compare AVB to some of the other systems that were proposed, and I think first of all we have to look at the fact that AVB is not intended for all applications. AVB is, as was rightly put, is intended for local area networks, for in-house installation basically. It's not intended for long distance carrying of audio or whatever. So from that perspective, I also see no competition between AVB and AES-67. I think it's more kind of that they can work perfectly together, as was also demonstrated in the presentation on Ravenna. Unfortunately, AVB was missing in that picture with interoperability. Last thing I would like to say is that if you look at the bandwidth management systems that are out there, most of the systems that are proposed, if they are based on the standard systems that are, let's say, used in the internet today, they all have problems. I mean, if you look at the AES-67, which uses diffserv, I mean, just a brief Google will learn you that diffserv has certain limitations and can't guarantee bandwidth. So if you're in a situation where you really need an application where you really need guaranteed bandwidth and you can't afford having one packet lost, then this type of QoS systems are just not good enough.
Thank you, Jan.
Good afternoon. My name is Paul Iger from ARG. I'd just like to point out that we are a UK switch manufacturer, and we have implemented an AVB build in our switch 2 years ago, and we've been shipping AVB switches for 18 months to customers. And we're also involved with some of the US companies that are looking at AVB. So I just wanted to add that to the conversation.
Yeah, that's a good point. There are actually more than 2 switch manufacturers, way more than 2 switch manufacturers that support AVB. So it's good that you mentioned this. Yeah, thank you.
The interest that we're receiving from companies looking for AVB switches is quite high. Thank you.
Good. Other points arising?
So I'm Andrew Hills from Clevehouse Audio, formerly of a console manufacturer. I just make an observation, really. There seems to be a feeling that audio over IP is a replacement for everything we've had before. And I pick up on Patrick's comment that maybe audio over IP is actually just another thing in our arsenal for system design. You know, we still have XLRs, we still have AES signals, we still have MADI. Isn't it just another bit?
Always. Always.
I disagree. I think it's just a matter of time before all analog dies. As soon as you can get networking into the back of a microphone, the next generation, if you look at the chipsets that the networked audio, whatever protocol you choose, are doing, they're going to fit into a manufacturer. As soon as the standard template for digital devices is and you can see that pattern with mixing consoles, it's happened with amplifiers. As soon as that product, the digital, and therefore these days networked version of the product, falls within 20% of the price of the analog one dies. You can't buy large format, medium format analog mixing consoles anymore. They do not exist. All high-end professional amplifiers have a network option. As soon as the cost comes down and the size comes down, my belief is analog. There may still well be some cheap Chinese analog, but apart from that, it'll just go. It'll just become irrelevant.
Actually, the business about the audio consoles, I think, is maybe a slight red herring, if I may suggest. I think people buy digital audio consoles now, not because they're digital audio, but because the ease with which you can manipulate, reset, recall, snapshot stuff is more relevant for consoles. There aren't very many microphones which have AES outputs on, even though technically it's been possible for a long time. I think there's an issue there that maybe we're going to continue, I think, for a long, long time with a mixture of stuff.
Yeah, I agree with that. I mean, I look at it more from the video angle, so apologize for that. But I mean, yes, innovations go very quick, and we all talk about these new technologies. But on the other hand, technologies also have a very, very long tail. I mean, if I get a euro for every analog output we have sold in the last 10 years, I would not be sitting here. So, and just the other week, we received an RFP from a big, well-known European broadcaster for CVBS analog equipment. So how long ago did we go digital? So what I think you're right. It's just one of the options. For certain applications, people will use it, but for many other applications, for a long time, also because there's legacy, they will continue to use the tools that we are all accustomed to, and which are also very cheap now. So that's, I think, how you have to look at this. So technology advances fast, but also we go very slow. I think that is how you can look at this.
Could you wait for the microphone to reach you? Then we can hear it.
Hello there, it's Mike Law, BCD Audio. I'm just wondering, what happens when the PTP time stops? When it stops, it's broken.
I don't know, what happens when your sync pulse generator stops?
Free runs.
That's right.
Or it falls back to something else.
So your question was, what happens when the PTP time stops?
Yeah.
Oh well, the world stops turning, I would say.
Oh no, it doesn't.
It actually does. It actually does. There is more out there than you can think of, which is based on PTP. There's all your power, the telephone system, is a lot of based on PTP.
I guess the question refers to what happens if in a specific or a certain network the grandmaster stops working. Well, first of all, the grandmaster, there is a grandmaster. That does not necessarily have to be a individual specialized device. Any of the nodes, at least speaking of Ravenna implementation, could serve as the grandmaster, and there's a best master clock algorithm involved in the precision time protocol by standard who selects the best grandmasters to serve the time. Usually in a professional installation you will see a GPS referenced grandmaster, which is serving the TAI, International Atomic Time, into the network. Now, the idea is that through distribution of time, each individual node is generating its media clock out of precise time. Now, that requires a oscillator circuitry aboard that device. So once the grandmaster actually goes out of service, it doesn't stop the network because the oscillators still keep on turning. And as long as the deviation between these devices is not providing slips, so in other words, as long as they're not running out of synchronization, audio continues to be distributed flawlessly. Well, of course, if the grandmaster service is out of time for a long period, that would be a bad idea because then the oscillators drift and you will have slips. Well, all of these networking schemes, be it AVB, be it Ravenna, be it Dante or whatsoever, are designed in a way that there's not just the only one grandmaster in the system. Correct. So once the best elected grandmaster goes out of service, the BMCA, the best master clock algorithm, automatically kicks in and selects the next best available grandmaster on a defined criteria list. So, in other words, any of the other devices, even if they are not the best grandmasters, can take over the grandmaster role and continue to serve the time. And that takes usually just a few seconds, and within that seconds, the individual time on the oscillators and devices doesn't drift too much. So once that one kicks in, it starts to continue serving the time and everything stays in sync.
So it's pretty seamless.
Yes, absolutely seamless.
And indeed, BSS and Peak Audio were dealing with this sort of thing in about 97, 98. You know, you have, you know, in those type of products, you had a conductor basically, but if you lost the conductor, something else took over. It was often a problem for us setting up early systems where the where the network randomly decided which was the conductor and not the one you wanted it to be. But these sort of issues have been solved many years ago.
Yeah, I'd like to add that in AVB, the requirement is that every device in the network that's AVB compliant, so the switches or in every end node, should be capable of becoming a clock generator. That doesn't mean they're going to be a very good one, perhaps, but any one of the nodes that is in the network can take over that role in the end. So that means a lot of devices have to die until there is no master clock anymore, but then you also don't have a network anymore, I think.
Thank you. I believe you have a question here.
Hello. Simon from Telegenic, Outside Broadcast. Could you just elaborate on the discovery and the stream management that Patrick mentioned? With Ravenna, you need to know the phone number, as it were. Does AES 67 demand that it's a plug-and-play network eventually? Because it's not, Patrick, you said it's not yet.
It was deliberately not included in AES 67 because there was no consensus on what it should be. That will be considered as an ongoing issue for standardization, but there's still yet no single clear answer to that question.
Okay.
Questions?
Thank you. Martins from Audio Express magazine. Mark, there's a standard in the industry called MADI, and I know there is a work group trying to carry MADI over Cat5. Can you update us on that and tell us how relevant that would be for this discussion?
What, the use of MADI within a network?
Yes.
MADI, otherwise known as AES 10, thank you very much, is one of a class of interfaces that I would call synchronous. I would include AES3 or AES-EBU and MADI, and also the time division multiplex stuff that Patrick's been talking about in that same synchronous category. The advantage of MADI and AES3 is that they can exchange signals with very, very short delays in the order of a sample. And so if you're dealing with a lot of audio signals that need to be in sync in a physically small area, it makes sense to use those. When the communication needs stretch to be larger than that, larger than, for instance, a music studio, then you have to think of some other technology, because MADI has a limited run.
Wouldn't it be the case that if you put MADI over Cat5, then you would do away with its principal benefit, which is that it doesn't suffer from the delays and indeterminacy of networks?
Well, you could put MADI over Cat5 simply as a means of getting it from point A to point B, but it would still be MADI.
Yeah, it's not network.
As soon as you packetize it, it stops being MADI.
Yeah.
But you're quite right. I'm picking up on what Patrick says, that if you want a tightly coordinated synchronous core, then MADI still has a lot to offer. And I would absolutely not ignore it.
Agreed.
Another question?
Andrew.
Sorry, I'll come back to a comment because that's pertinent. Actually, we haven't talked about the cost per channel, because stuff like MADI and AES is actually pretty cheap on a cost per channel, whereas once you start encoding and packetizing, the cost does go up. And in the very large, high-capacity, high-density core of your onion, maybe traditional TDM has its advantages.
It may well do, because I haven't seen any figures and I can't quote any costs, but what I can say is that in the I'm pointing up there, it's the wrong slide. The blue boxes on the slide that I showed you before, which are 8K squared TDM switches, the cost of those in terms of the silicon is very low. I mean that 8K square switch is implemented. It was designed a few years ago, and it's implemented in 2 FPGAs that just cost $100 or something. And with Moore's law, it's going to get cheaper and cheaper.
I mean, what is cost per channel actually expressed? Is it cost per channel on the end node implementing that channel? Is it the cost of the channel running through the network? Is it overall cost, maintenance cost? What is it actually? I mean, standard network infrastructure, just a plain €100 gigabit switch can carry already 500 channels of audio. How much would that cost with a proprietary audio routing system?
I was actually referring more to the interface box. You know, you need something to convert from your internal format within your DSP, within your I/O frame, whatever, into a format that you transport from point A to point B.
And you're right. Specifically, as MADI is becoming more and more available in the recent, I would say, 2 years, a lot of MADI implementations were popping up, a lot of silicon is available. That decreases the cost per channel of implementation and end significantly. But we may expect that with networking standards now being established, that the cost per channel, once the technology is pressed into silicon as well, will decrease adequately. And I know of some manufacturers who already provide relatively low-cost implementations of Ravenna, for example.
Yes, well, my laptop, if I put a Dante driver on it, then I get 64 channels of audio for free.
Yeah, same with Ravenna.
Hi, my name's Adam Peters. I'm from the University of West London. We have a very large studio complex, and we're currently running a Dante network across them. Now, the biggest issue we have is access rights and port protection. Students being students quite often, they're learning to use the technology. At the moment, we have to run each room, each studio as a separate node, and if we want to connect the studio to the wider network, we have to physically go in, plug in a cable. Now, from listening to the talk, so far the Hydra 2 system is the only one that seems to have any control over the access rights, because what we don't want is students accessing other students' recordings, because everything's going to be transmitted onto the network. Is this something that you can see a solution for soon, or is it something that you don't think there'll ever be a solution for with the AES 67 standard?
I think it's going to be very important for the reasons that have been given at various times during the morning. It's not part of AES 67, which is an audio interoperability standard. Will it be important? Yes. Will it need to be standardized at some point? I believe yes. Exactly what that entails at the moment, I don't know. Andreas, do you have some idea?
Well, actually, the technologies have been introduced this morning are all covering the transport mechanisms, making it possible to have lowest latency, synchronized audio distributed across hundreds of nodes, lots of switches in smaller or larger network environments. Patrick brought up this onion model, the layered model. I look at this question actually pretty much the same way. We have the lowest level is the physical infrastructure. Then we have the protocols on top of that. Then we have the stream management stuff, which is already partly outside the pure distribution and synchronization mechanism being covered by other applications. And also we have the security stuff, which is also a totally different level on top of that, which makes user authentication, access possibilities, visibility of streams and stuff like that, all that available to the outer shell, to the user interface. And it does not depend on the actual transport technology used. It does not depend on Ravenna or AVB or even maybe the Hydra 2 system may apply to it. It's a level on top which would provide this kind of functionality and then works through clearly defined interfaces its way down. Very similar to the OSI model. You have the whole networking stuff based on models where you have one layer working towards the other layer. And I look at this pretty much the same way. So there needs to be this functionality from the end user perspective, absolutely, but it's so different comparing one application against the other one, how this should be implemented. And I know there are companies out there who have provided some sort of access as part of their solutions, and we have other manufacturers, primarily in the broadcast area, where they have huge management systems which do nothing else than just managing the whole infrastructures with all the access rights and stuff just mentioned.
And indeed, this is something we highlighted many years ago. I wrote an article in 2008, which is actually on our blog. I sort of republished it last year on our blog, which has a fictitious story of a war starting because hackers hacked into the network and changed the translation and diplomacy fails, which was obviously a facetious argument. But other people are solving this problem. The problem isn't really, in my view, port access and things like that. It's just encryption.
I agree.
And if you had each stream was given a token so you have access to that, it doesn't matter how it works. If you haven't got that token, you can't receive it. And people who make conference systems got that sorted because they know their stuff's being used in banks where important financial decisions are being made. So those people have sorted it, but people doing stuff for music concerts and things, aren't. I don't know why they aren't, because you have just as significant financial implications if someone can take a fantastic uncompressed split off a switch and then flog that on the internet. You've lost all your album sales. So to me, it's an encryption issue, and that's been solved by plenty of people, plenty of times.
Yeah, I agree with that. It's not only just because people stealing things, but it's also to avoid on-air mistakes. This might be important. We know all these horror stories where adult programming got on a children channel somehow, and that's another example of where you want to have some kind of control where certain content goes. And I think the only real good way to solve this is again encryption of streams. The disadvantage, of course, of encryption is it will add, again, a little bit of latency somewhere. So, and this trade-off again.
Thank you. This probably needs to be the last question before lunch. Chris.
It was Chris Jenkins, Solid State Logic. It was just to say that there is a third-party solution that manages a Dante network, which is made by NTP. So that they do a router that will manage a Dante network, and you can do all the sort of blocking and whatever you want to do. So you're not locked into just using the Dante routing software.
Okay. Thank you, Chris. Right. Unless there's another urgent question, which I don't see, there's something more urgent now.
I had one, yeah. Which was...
Hello, Zen.
Which was the 3% that I saw on one of Roland's charts, the ones at the end when you said tiny. So it's two ways of looking at it. It's either room for massive growth or it's not capturing the popular imagination. I think that's, if this was to really take off in a massive way within our industry here, then it would probably be a little bit more than 3% at this stage, I can't help thinking. Because we are concentrating on quite specific areas of it. There's very little sort of networking going on within day-to-day music recording, which is by far and away the biggest area of the market here. So next year, when you have your figures, what do you think that 3% will look like?
I don't know. As I said, that was just an anecdotal figure when we think, how many systems are networked. And I come from a slightly different market because I'm mainly associated with install sound. To be honest, I think in the next 12 months, I don't think it's going to change very much. And the simple fact is, it's just still too difficult to do. You've got to be fairly intelligent and to have the confidence in that it's going to work for you. And that involves using expensive equipment and employing expensive people to ensure it does. We're miles away from it being plug and play.
Steve Sanford, Clearcom. Is the lack of a Cisco AVB router kind of hindering the AVB take-up?
Well, I think it's just a matter of time.
I spoke to Cisco about a year ago and they had no plans. They didn't even know what it was. To be fair, I know they sit on the AVB Alliance, but they didn't even know what I was talking about when I mentioned AVB.
Unfortunately, you talked to the wrong people.
Let me add a comment. This 3% figure we just mentioned is 3% of what the audio industry is currently just using networking. Now imagine how much the whole audio industry, if it would be networking, using networking, would mean to Cisco in their whole data world. The whole pro audio world. Maybe it's just as much as these 3%. Would Cisco really care to do some special switches, some special functionality, just to make us here at the pro audio community happy? That's the reason why we use standard equipment, which is already out there, which can provide the protocols and the functions we need. Just my 2 cents on that.
Yeah, I think it's not special, as I mentioned before. And don't forget, there is all these factories and so on, which are also going to be equipped. That's a much bigger market than all this industry. So I would be careful to rule that out.
The fact is, though, there's been this, next year it's coming with AVB for quite some time. I've been fairly vocal in suggesting that within what they call the Pro AV market, it won't succeed. And it's not because AVB isn't technologically very good. I mean, Cisco being on there is a red herring. Cisco got 2 people on everything because they need to have that, you could say, well, they've got 2 people, or they're a member of the Avenue Alliance, but they've also got a strategic alliance with QSC, who make an AES 67 compliant thing. Of course they can afford to have people everywhere covering all the bases, seeing what's what. The fact is, in terms of products you can go out and buy, there's less than 20 models of switch available that are AVB compliant today. Whether firmware would be updated or not, no one knows, but it's not been done by anyone. And we've been 6 years now. And it's one of these things that's always tomorrow. I mean, so as I said, I've been vocal saying, one day they'll be right. But, plenty of other technologies would have come and gone by then.
We're not going to answer this one before lunch, I suspect.